Twitch stats updated, right? OBS seems to be behaving fine. Cool. Twitch stats are updating. Awesome. Right, let me actually add a scene real quick for get cracking. Right, get cracking. There we go. Yeah, I think that's visible. Let me see if I can. Can I set the UI a bit bigger? I'm wondering. Editor. No. UI, there we go. No, okay, I hoped it would be here. Anyway, I think that should be fine. Should be fine. I just hope it's fine. Right, so the first thing I actually wanted to do in this stream today was work a bit on the planning. Because as you can see, the planning is kind of very basic. So I wanted to basically add a bit more to the things, and even here, right, it just add scenes and allow for changing scenes. I think that's fine. Button volume hierarchy, sure. So for the button volume hierarchy, there are actually I just want this to be slightly different, right? So this is just for models, right? Because I decided to change that a little bit. Right. Then I want another card, bounding volume hierarchy for scene. Let's actually just do the short-handed, right? BVH, sure. So what do we want for this? So we want the ability to build a BVH for a scene and allow for updating. Right. And for tasks, we want to simply have the create BVH and rebuilding of BVH and traversal. Right. Same for this. So we feature. Yeah, we can just give this feature as well. Okay, I need to take off my shirt real quick. It's so hot in this room. Holy hell. Yeah. Right, that's better. So, for anybody interested, right, my room is quite small but has a quite large radiator, and it's either like ice cold in here, right, or it's completely freezing in here. It's like never perfect. But sure. But now it's in the really hot mode, so just a t-shirt is more than enough. Right, so this is a feature as well. Sure. Tusklisk. So building with PVH and traversal PVH. That's for now fine. Then something I want to add is I want to add MGUI to the Raytracer. So what are some things that we want in here, right? We would want in here frame counter. I would want a normal view. Normal view button, a BVH, that button. That will allow us to basically see how deep in the BVH we are. Maybe, yeah, scene info. And real-time Raytracing editing. So erase per pixel, for example. So we can edit those on the fly, what I think would be quite cool. Then I want to work on reflections, refraction. Texture should be added at some point as well. Anything else that would be good in here? Maybe GLTF support? That could be interesting. Yeah, I think for now this is a few tasks to keep us busy. So this is also a feature. Right. All right, cool. So let's add another tab for bugs. So just we can label. Oh, yeah. So just we can order them a bit better. Yeah, currently there are no bugs, or there probably are, but not that I know of. Right. I think this should be good for planning today. I don't think we're gonna get this all done. I mean, we're not gonna get this done by a long shot, but this should be good enough to keep us going for a few streams at least. Right. So let's switch back to Visual Studio now. Right. So last time, or last stream, I mean, we got the cow up and running. It has very basic shading just to get a bit more information on the depths. It doesn't have shading, as in well, I mean, it has shading in here, but that's simple bling fong. But it doesn't have shading in the sense of what do you call it? Like lights, right? Oh, you know, I just realized something. Right, this is a CPU Raytracer, so I mean, it's barely using the CPU. But one thing I would actually do, right, in the main, we're actually creating a job system. Sorry, this should be in job system.h. Where is it? Job system.h, right. So let's add a quick define here, because I just realized something stupid. Right. So, while streaming, of course, I use CPU cores, or my CPU gets used, right? Sorry, my CPU gets used, and it's a CPU Raytracer, so it completely throws up my GPU. So if I start debugging, my PC is gonna lag. So, what we can simply do is in the constructor here, right? We set it to num of cores, and we simply say minus reserve cores. So for now, I got 8 threads, 16. Sorry, yeah, an 8 core, 16 threads. So we're simply reserving one of them. I think that should be fine. Let me see if I run it now. If the frames are dropping. All right, let's see if this is better. All right, no, okay, it's still okay, no, okay, it took a little hit, but it seems to be better now. All right, the stats are actually helpful. That's cool. That's cool. Yeah, right. It's a bit dropping sometimes below 60, but that's okay. Right, this is much better than before. Before we were running on like sub 30. Right. Small fix, but yeah. So reserve cores 4. Right, sure. Small command there. OBJ loader can go. We don't need the main camera. Cool. So we were building a BVH, right? Yeah. So what we got last time, we had the ability to sort along an axis and find the pivot points. Now we simply need to calculate the BVH. Yeah. So in a triangle, I want a simple a const std array of GLM of type GLM 3,3 reference get verts. Right. Because for the BVH we need to know where the actual vertices are of the triangle so we can encompass all the triangles, right? So generate implementation, and this can simply return vertex, right? And this function itself is also const. It should give me the ability to. Normally the resharper should give you the ability to say, hey, this function can be const. Do you want to change it? But apparently here it doesn't. But that's fine. We can simply add it ourselves, right? Yeah, right. So find the pivot point, right? Find the pivot point. Then we need to actually calculate the areas, right? So we have float one. Right, yeah. So you have glm vec3 bounce left. This can be just empty, and another glm. Sorry, it should be an array though. Although let's just make it an STD array. Just that. No. This is fine. It doesn't need to be a. I mean, maybe we can change this later. Bounce right. Right, cool. And that's done. Right. Oh, I don't actually need to. No, I do actually need to loop through all triangles. I thought I could take a shortcut because the triangles are already sorted. However, it's the centers that are sorted. It's not the actual vertices, so I still do have to look through every vertices to calculate the bounds. But we can simply do this in a single for loop. Right, for E. You know, I don't think we actually have to do this, right? Because for this part, we don't have to know the pivot. No, we don't. We don't need to know. Right, the pivot is very important later on, but it's not now, right? So we can simply say, we can move this up here, and pivot plus plus is here is important because we do need to know that. And then we can simply say that we do need a small for loop in here. So this is vertices, and this is simply 3. Because it's a triangle with 3 vertices, right? So we have bounce left dot 0 equals glm min model dot triangles triangle dot get verts, and we can store this here so we don't have to get it every time. Right, I think this should work. Model triangles. Why are we still complaining? Oh, right. Of course, I need to give it a name. Vertices array, right? And let's default initialize it. Right, cool. So now we have the vertex array, and then it's simply vertex array and bounce left. Zero. Right, we do actually need to initialize bounce by something. It's the same as the triangle. No, where did I initialize it? So we basically need to initialize it to infinity. So that way we can easily check it. where did I set the... I had somewhere where I put the things to infinity. I'm comparing it somewhere. Let me double check. So min. Right, do I only have it here once? Where did I put it then? Oh, did I put it in the... I think I put it in the obj loader, right? Right, obj loader, right. Yeah, here we go. It's in the... Oh, it's actually defined in the model. Right, I remember. Right, so it's this part that we want to copy. GLM, yeah. No, did I just close the model? That's fine. Right, copy. Trying... No, BVH. BVH or CPP, there we go. Let me actually pin this so I can find it easier. Right. So initialize this to blam, blam. There we go. Yeah, like that, and then bounce right. No, sorry. Bounce left dot 1 equals glm max vertex array dot y. Is that? No, sorry. Dot vertex. Oh no, it shouldn't be y. This should be vertex. Let's actually rename this to vertex. So I think that's a bit clearer. So the vertices. Right, vertex array, and then bounds dot 1. Right. So this will basically give us the minimum, maximum values of the bounds. Right. And instead of breaking here, we basically do the same. But then this is bounds right. Bounds right. Right. So this sets up yeah, right, and this calculates the right. This way we only have to go through the entire array once. Right. Right, that should be correct. So let me just double check Twitch if everything is still working as expected. So normally I have Twitch itself open, right? But I switched to oh, shut up, Twitch. Right, so normally I have Twitch itself open, but now I changed it to having Docker modes in OBS. What is a bit more info that gives that's a bit more powerful. So I can change the title actually from here. I can see viewer count easier. I can see how long I've been streaming, clips, just general stats of the channel. Also, who has been following, stuff like that. So it's quite powerful. Right, but anyway, enough of that. So if I go here, right, let's see if this works. Oh, no, ships. Yeah, I already found a problem. I need to run this in debug. Right, so that works. So bounce. Right, I already see a problem. This should be bounce right. That's why I don't like copying the code, but I also don't think it's worth making a function for it because it's such a small piece of code. But mixed things. Right, so bounce right. Let me just delete these watches. Clear all. Add to watch. Right, of course I can't actually view them because why would I be able to? Oh, did I? Right, where did I define them? Right. Yeah, no wonder they died there. Right. Right. I think this should be good, right? So the pivot is still 1. If we go here, yeah, right. This is now correct. Now bounce right. I think we can actually see. Let me see. No, okay. So we're out of scope. That's kind of annoying. Let me just put a int a here, right, just so that I can put a breakpoint here easier, and then just let's rerun it. Come on, breakpoint trigger. Okay, that doesn't work apparently. Let's just assign it to something so the compiler doesn't strip it away. Visual Studio, can we run that? There we go, there we go. Right, so bounce left. So pivot now is 161. That seems sure. I'll believe that. So X, Y, Z. Sure. -1, 1. That looks perfect. I mean, I'm just guessing here what is correct and what isn't, right? Because we can't really test it till it actually runs. But this looks like correct values, at least in the sense of the boxes. Right. Right. So now we're pretty close getting this working. So what we have done, right, is we've subdivided all the objects, or at least the current node, sorted them based on the pivot points. We calculated the boxes that would be around those shapes. So all we now need to do for the binning to work, I mean, we have to do more, but one of the steps now that we can do is calculate the surface area. So let me see if there's an easy way to calculate the surface area of a box. Because, I mean, I know how to do it, but... Oh, wait, is it just with... Yeah, I am actually stupid. It's, Oh, really? That's interesting. Okay, right. So, apparently, in general... Blah, yeah, so the surface area is just 2 times length, length times height times 2 times... plus 2 times... L, yeah. Right, sure, that's actually really easy. So, it's... right. So this is the formula for... Really? Can we not? Right, so S equals 2LH plus 2LW plus 2 HW. However, times height, right. So GLM vec3 length equals, I think I can just do GLM distance bounce left dot 0 and bounce right dot 1. Although I'm guessing this fails because this yeah, this simply returns a float, right? Yeah, so I want components distance. Right, so that returns... it's not the dot product, so distance, right? Returns distance between... Yeah, what is... returns a value. So the distance function simply returns the actual distance. What we don't want, but we want rather the... what do we call it? Like the component-wise difference. Because we could. All right. I mean, there is easy ways to do this, right? But I was hoping I could simply use a glm function that would return a component minimum, and not the actual like or geometric distance. What is a shame. So we can definitely do this, but so length of x, right? Right, sure. So we initialize length, and then yeah, I mean this does work, but that's very iffy. Oh, but you know what we could do? Yeah. So we can just do box left, and it's a bit cheesy, but it should be fine. So we can do this. No, there we go. And I still need to fix a bunch of things in here, I see already. Right. So this simply does the component-wise distance, sure. And they should all be of bounds left. And why are we complaining? Oh, right, yeah. Yeah, I see why. Because I did it. See, right, there we go. That should be correct now. Let me double check the. Yeah, there we go. I messed up the brackets. Right. So this should simply give us the size of the left box, and let me double check this. So left, 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 set, right. And then we can do box right, and this should be bounce right. And then we have a simple float. What is total surface area, and this is equal to let's actually make two more. Float surface BL and float surface BR, and this is equal to surface BL plus surface BR, right? So this equals 2 times BL dot 0. Let's just take x being, I mean, it doesn't really matter what order we take, right? So let's just make a comment so it's a bit easier. So x equals width, y equals height, and z equals length. Sure. So it's dot z times bl dot y plus 2 times bl dot z times bl dot x plus 2 times bl dot x times bl dot y. So you have 2 times x. Yeah, they should be correct, I think. And they should be br. And then we can simply replace all the bls with brs. Right, cool. And now we got the surface area of this box. And now that we know this, right, so if total surface area is less than surface area, then we want to say final split point equals current split point, and final axis equals current equals axis, right? Oh, and surface area equals total surface area. And y, oh right, we need to cast this to a static cast to e-axis, right? And now if we run this, we should see this being triggered. Let's give this a go. That looks reasonable. So does this get triggered again? It does. So this is a bit smaller, right? So this is the beauty about binning, right? We can see here. I mean, it may not make complete sense, but we're splitting the axes, or sorry, let me rephrase that. Sorry, I'm a bit too excited. So we're trying to subdivide triangles in space, basically. And with binning, we're basically trying all the axes in a bunch of positions and just seeing, hey, which one is the most optimal. So we can see that, hey, this one is a bit better. Maybe we have an even better one. Yeah, see, this is one surface area smaller, or 1 unit. This one is also a bit smaller. And at some point, you will have the optimum surface area. And then you know, right, on this axis and this point, I want to split. And then we know we have the optimal splitting position. Or there are a method to get a bit better splitting, but with the binning, it's a very good estimate of what ideal is, right? Because we're in here, we simply define number of split is 16, so it means we're trying 48 different positions in equal increments along the area that we want to subdivide. So it will give us a pretty decent guess of what is the most optimal thing. We could do it for every triangle, but that becomes quite expensive to calculate. This should be plenty for our needs. Right. So then, right, just to double check. So we got this. We're done with this. Right, so here we calculate surface area of the resulting 2 boxes, right? Cool. Right, so now we partition this. And this simply returns at the moment just the pivot. So we can just simply return. Right, we do need another float here as well. No, sorry, we need uint 32 final pivot. And then final pivot. Final pivot equals pivot. Although I'm actually debating if we need to I don't think we even have to store the axis and the point that we split on, right? Because that doesn't matter, because we already sorted the No, that does matter. Right, yeah. So why does this matter? Because we actually need to sort it one more time at the very end. Because we keep sorting it, we test all the possible methods, but then we actually know the final one, and we need to sort it again. Yeah. So then we simply, at the very end, before we do this, so std sort, yeah. So this is final axis, and triangle A, triangle B, sure. And this is final axis, and yeah. But we don't actually need the point. We only care about the axis. Right. Do we? Yeah, I think so. Right, but we're going to actually need to return a bit more here. So let's create a struct here. So struct partition info, right? And this can just simply contain some information. So yeah, we want to e-axis split axis. Then we want an u32 pivot. And let's, instead of this, do a partition info, and simply default initialize this, right? And then in here we can simply say the final axis is info.split axis equals axis. And then we do need to cast this to an integer again. Static cast un32t axis. Were we not happy here? Oh, sorry. This is should be pivot. Oops, my bad. No, wait. Oh, no, we don't have to cost. What am I doing? It's an e-axis, so we can just set it simply. I mean, in theory, we could set it. Oh, right, sorry. Yeah, so this should be e-axis. We actually need to cost it the other way around. Cool. So, and then info.pivot equals pivot. Cool. Final split point is currently not used, so we can delete that. Final axis. Right, do I still need this anywhere? Yeah, so this should be info.split axis and info.split axis. That should be a un32t. Static cast, right. Right, it's not captured, right. We do need to pass it in the lambda. And then, right. So where is the lambda capture? Right, so this should be just, you pass it by reference and we pass in info, right. So we got that there. So now that sorts based on the info, then we don't need the final pivot here anymore either, and we don't need the final split point. Then we need a float in here. Float surface area, and this can be an array, and then float right. So info total surface area equals total surface area. Info.surface area.0 equals surface BL, and info.surface area.1 equals surface area BR. Right. And then we want to return info. Then we do need to change this function to actually provide me with this definition. So we do actually need to find this in the header now. In the namespace, right, there we go. And then they should return partition info. And we do actually need to copy this by value because it's we need to copy it by value because it's a local variable, right? And it should be fine because it's not a massive data structure to copy, so I think it should be fine. Right, so now we partitioned it, then we sort it again. We do need to cast this. Cast. Right, so in the optimal right. So now if we go here, we should see some decent info. Step out. Right, that's right. So pivot, right, so cool. So we split along the z-axis apparently. The total surface area is 255 something. The pivot is position something. Right, so apparently in this case it was the most interesting to split it like this. So we have one very big box but and a very small box. What apparently provided the best surface area. What is fine. But right, so then we partitioned the data. We now need to get the escape though. So the escape is based off the surface area. So if the surface area of the best-in node is smaller than the resulting surface area, we don't want to split because then we're doing something wrong, I believe. So we would pass in even more values. Yeah, let's pack this just nice in a struct as well. While we're at it, struct partition. No, sorry, this should be subdivided info. Oh, and this, this can actually be simply in the private part. Yeah. So this will simply contain the RT model. Yeah. Right. And then to keep naming consistent, we do need to capitalize this. Sorry, should be first and then count. Right. And then I also said we needed to pass in the UN32T with current node surface area. Right. And then we can change this to subdivided info instead of this massive mess. Do we want to? Yeah, we might as well pass this in here as well. and then we pass this in by reference. Oh, no, I messed up something. This should not take from the partition, this should take from the subdivide. So this should take, yeah, we do need the model, we need the left, sorry. So this should be called left and pull pointer. Right, we're copying the wrong function, pull pointer. Pull pointer, so left, model, and this. Although I don't want to pass in the, I don't want to put the note in there. So this will have a subdivide info reference info. All right. Subdivide, and then there we go. Then we do need to change this to RT or subdivide info, and that should be model 0 and pull pointer. Right, and then we can just this is info. And then we can simply pass in info here. Right. So this is a bit more flexible. If you want to simply add variables to the function, we can simply gather them. We can add them to the info. And now the function definition doesn't become massive. And that should be info.model then. And info dot left. Right, cool. Right. Why is this so complaining? Did I by accident change the function definition here for the partition? I don't think I did, but let me just double check that. No, that should be correct. Oh, is the partition... No, the partition is right here. No, we do have this function. Interesting. Do I need RT? Partition info? Interesting. Cannot resolve partition info, but it's defined right there. What do you want? Could it be that no, because it can find subdivide info. Would I, if I make this public? Oh wait, it's rt bvh dot partition info, right? Interesting. Alright, sure, that's fine. That's fine. Now that's working, that we sort it. Do I care that... No, I don't actually care that it's sorted. That's fine. As in, if the final node shouldn't subdivide further, right? It's fine if it's sorted, because in the end, we simply intersect all the triangles in the nodes. So, or that's left in the root node. So, if it's sorted in there, we don't care. So if pivot dot total surface. Actually, this should be partition result. Right. So if partition result, the total surface area is less. Wait, why is total surface area greater than info? Right, so the subdivide should contain a float surface area as well. Right. And this is set to infinity by default. So if it's greater than info.surface area, then we return. So this is the right. So this is our escape. Right, because we can't escape before we actually calculate the ending condition in this case. Normally we do it on the very top, but in this case we can't without partitioning first, right? So in case we don't actually return, so say our partitioning actually makes sense to do, then we want to call subdivide again, and then let's create subdivide info left and subdivide info right. So for their left and right nodes. So what do you want in here? So you want the, can I do this simply with info? Right, so let's just pass in info.model. Right, then we want to pass in partition result dot. No, sorry, we want to pass in info.left, info.left, info.pool pointer, partition result dot surface area dot 0 for the left node. That's the surface area there, and oh, we actually already had this value. Oh, this shouldn't be this shouldn't be a uint. This should be a float. That's why I didn't read it. So this is equal to floating point infinite, right? Cool. So this is info dot current node area, right? So and this should be surface area 0. So what else was I missing here? No, I think this is everything, right? So we pass in the model, we pass in the left, we pass in the pool pointer, and we pass in the node info, right? So this should be info.model, then partition result.pivot, then info.pool pointer, dot surf pool pointer, and then partition result dot surface area dot 1. Right, so now we got the actual info that we want to pass on to the next subdivide. So for the left node, it's still the same model. We start on the very first, with same pool pointer. We still have the same partition result. So we take the surface area of the left node, and for the right, it's very similar, but instead of the very left, we take the calculated pivot point that we did earlier, or as in where in the array we split. So it's basically just an index, and the actual surface area of the second node. And then we subdivide right, so we do actually need to initialize we actually need to initialize the BVH nodes. So we want a rt bvh node reference left node equals m.nodes dot info dot pool pointer and rt dot bvh node reference right node equals m dot nodes info dot pool pointer plus 1. Yes, right, that's correct. So what did we need to set in the BVH node? We need to set the, oh no, I don't want to take a screenshot. So we need to set the bounds, the left, and the count. Sure, that's easy enough to do. Oh wait, that meant something different here. Let's think about that in a second. So for the bounds, we do actually need the partition. The partition info doesn't actually contain the bounds. So we want an std array with glm vec3s. And this is of size 4. And this is, well, let's just have 2. Left bounds and right bounds. Although, yeah, let's just right bounds. And then in the BVH, we do need to set this as well. So in here, we simply say info dot left bounds equals we do need to actually set all these values individually. What's kind of, although no, I think we can just simply do this and construct an array in place, right? So this is bounds left dot 0 and bounds left dot 1. And info dot right bounds equals bound right and bounds right dot 1. Right. So now we have the bounds info as well. Right. So left node dot bounds equals partition result dot left bounds. And right node partition result dot right bounds. Right, cool. Now I need to check something else from an old project I did, because the left and right values are a bit finicky in the sense that they mean different things. If it's a root node, they contain indexes to the actual array of shapes. But if it subdivides it, oh no, yeah, no, okay, right. So if it subdivides, it's the pool pointer. If it is the root node, it's an index in the array. Right. So, so before we return, we set the current node dot left to be equal to so this should be info dot left, I think. Yeah. And current node dot count equals info dot no, didn't I have a didn't wait. Let me double check how I did this before, right? So in the build BVH, we subdivide. Blah blah blah. Yeah. So yeah, the left is that. Right, and if it's not, it's the pool pointer, right? And the count is already set. Yes. Oh, right, yeah, because if it's set to 0 by default, right? So, yeah. Cool. So we set that because that basically means that, hey, it's the this value in the array. However, if it's not this, it should be left node dot left is equal to pool pointer. Sorry, so this should be info dot pool pointer plus plus. Actually, if it succeeded, it's not. Wait, let me just double check here. So it's equals to first, and then no, this is also equal to info dot first, info dot left, sorry, and then left node dot count equals pivot index. Right, and then the right node oh right, so this should be right node dot bounds right node dot left equals info dot left plus partition result dot pivot, and right node dot count equals current node dot count minus partition result dot pivot. Right. So then we set up the info there. So we calculated the bounds. Right. Cool. So this is setting the left node, right node, getting the subdivide info. Let's move that with their respective node as well. So it's a bit clearer what we're doing here. And then we subdivide again. And current node equals current node dot count equals 0. Right. Because we set the count to 0 here because we can indicate that, hey, we don't have actual children, we just have nodes, and the left indicates either left or right node. Subdivide. That was left node and left. What did I call it? Oh, just left. Right. And then subdivide right node, comma, right. So let's actually rename this to rename, refactor, rename. So left, left info, and refactor, rename, right info. Oh, and this shouldn't be spelled with a capital because it's a local variable. Refactor, rename, left info. There we go. That should be correct, right? So this should theoretically subdivide. Let's see what this does. Let's see how many nodes, if we get anything that makes sense. I mean, we might actually get a crash. Oh, it actually runs. Okay, that's great. So, locals, bool pointers 3. That's interesting. Right, so this nodes. Right, so we only initialized, it seemed, a few nodes. What is odd? Right, let's restart and view the view this. Right. So the total surface area is this, and this is, that's interesting. Why is that equal to 1? Oh, this is not set to infinity. Right. FB. Right, so that should be infinite by default. And then pv8 to cpp. Right, let's rerun this and see if it now subdivides more. Because that's 3 subdivides is not enough, clearly. This nodes. No, that's still not a lot, so it's still 3. Right, so why is it only 3? That shouldn't be. Right, let's debug this again. How is it 1? Right, let's rerun it again and breakpoint this. So the subdivide info. Info, right? So. Oh, wait, you know, we don't actually have to pass an infinite here. We can actually very simply just calculate the area here. Because we already have the bounds of this node. So why don't I simply steal this code? Right. Yeah, no, I only need the first. I only need this part, right? So info. Right, there we go. So there should be area, and there should be not bounds left. There should simply be. I'm not node 0.bounds. Right, it's a bit of a long function, but it should be fine. We can actually simply do this and this to make it a bit more readable. Calculate area. And then pass in the area. Cool. Oh, did I make this but it's a, why do you say it's a, oh right, yeah, this is actually, so this is just the size of the box, right? Box size, and then, right, sorry, my bad. And there should be box surface. Right, cool. So now if we go here, this should actually give us the proper surface area of the cool, of the thing. However, it's not that big. So I think this will immediately return with pool point 33. Yeah, because this surface area is 255, this is 248. So let me see how surface area heuristics does it. Right, so what is the right. Right. Oh, I'm calculating this wrong. I'm calculating the exit condition. It's not it's not this, right? It's something to do with probability to hit the node, I think, right? So what is the exit condition, right? Right, blah 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 blah. It's versus one, yeah, sure, blah blah blah. Doesn't matter. Okay, I found a lecture by one of the people working on ray tracing. Right, surface of blah blah blah. I need. Come on, lecture. Give me the exit condition. Right. Right. So, I think the exit condition is a. Right. So the cost of a split is the area of the left node times the number of objects on the left node. Right. So we want to see if the cost of it is worth it. Right. So area times number of objects. Right. Okay. Cool. So the surface area is fine. However, it shouldn't be simply surface area. What's still important factor? All right. So no, we still can keep all of these, sure. But instead of this exit condition just simply being what it is in the project S and simplified here, right? So this should be a bit. This is actually a bit more complex, right? So if partition result dot surface area dot 0 times pivot times partition result dot pivot plus partition result dot surface area dot 1 times info dot so this should be current nodes dot count minus partition result dot pivot, right? So this will give us the No, wait, the count is simply... no, it is correct, right. So if this is greater than the current node area times current node count, then I think we subdivide. We stop subdividing. So I think this should be a better formula. This should be the correct formula. So let's see if we now actually get a bigger number of subdivisions. At least it doesn't breakpoint immediately, so that's good, I suppose. Unless it never stops subdividing. Right, I don't think it ever stops subdividing. No, wait, that doesn't make sense. Right, but now we're definitely getting more subdivisions. Because we're already on 15. Right, sure, let's keep this going and see if it subdivides, if it stops naturally at some point. Because if not, we should simply get an out of bounds error. But this is taking a long time. This shouldn't take that long. Even if it's running on debug, right, it's not a super complex something to run, I would say. Because although it's a lot of options, it shouldn't be that expensive. Right, let's run this in release, right, and see if it crashes. Fingers crossed this should be fine. So if we see the model on screen, it should all be good. Hopefully. So it seems the BVH construction is very expensive, but we can look into that later. It's way more expensive than I actually expected it to be. Because we aren't doing any extremely heavy operations, but this is mostly simple multiplication and comparison of integers, so that should not be that expensive, right? That's actually really slow. Holy. So one of the things I could see what could cause potentially this issue is that it would be splitting indefinitely, but then it shouldn't be caused, or this shouldn't be caused either, because this should be done instantly. Although it's single threaded, right? It shouldn't be. It should be fine. Right. So where are we currently, right? Yeah. So it's somewhere very deep in the hierarchy. That is surprisingly long. You know what we could do? In the Raytracer, right? So let's try a different model. I think it's arrowed obj, I believe. Right, so let's see if this runs. Right. No. Of course it doesn't run, because why would it, right? So there isn't actually like any safety in place for not finding a model currently, besides simply crashing. Right, let me double check what the model is called. Give me 2 seconds. GitHub. No, it is arrow.obj. That's interesting. So it should simply be this, and it should be able to find it. Unless, wait, let me try something. It might not be in the executable folder, so it might not find it. What would still... No, it's in there. Huh? How is it not able to find it? Huh? That's odd. The cow is fine, right? Okay, wait. Let me just break. Let me see the output in the thing. Right. Oh. Wait. No. Wait. This is right. So I'm stupid. Right. So it did find the obj, but I actually didn't read the error message. So it, it was actually in the BVH creation. So float costs. Right. So let's see. So if cost is greater than, yeah. So let's see what this does. Right, so cost is 92. Right, and this would be, how much would this be? Right, so this cost is 97. Yeah, so this is 97-ish. And the cost is 92. So we subdivide. Right. So if we go again, the cost is 77. Okay, sure. And now this is 77. 007. Oh. Wait, so is this just less? Wait, this is the exact same, isn't it? So 77.07 to 705. Right, so let's say if it's greater or equal then. But it's floating point, so let's say if cost minus is greater than, right, I need to think this just correctly. So if this minus cost yeah, sure. So do we now actually access successfully? Hey, now we stop the subdivision. So do we now still get the out of? No, we don't. That's massive. That's actually massive. Right, this is awesome. So if I look here now, all right. So if I look in the what is pointer 7? I can believe that. That sounds fine. This nodes. Right, that seems fine. Maybe. Maybe not. I'm a bit concerned why it's set up like this. Because that is surprising. Because let me just simply add the node to the watch, right? So it's a bit easier to see and debug. So let me make this a bit bigger so you guys can actually read it. Right. So what is surprising to me is that in here, right? So this is node 0. So the left is index 1 and the right is index 2. However, the left should be equal to something if it continues down, right? Because node 2 should refer to node 3. Node 1 should refer to node 3, and this should refer to... It's a bit odd that it does this, but we can, especially since it's such a small model, we can debug this very, very easily, I think. Because I think this is simply an issue with assignment. And if that's the case, it's going to be very easy to debug, right? So, right, so we restart. So this is the first subdivide. Right. So this is pool pointer's current. Right. Yeah. Right. No, it is actually correct, the info, but we simply got the wrong info because we're moving this pointer along, but we're actually not setting it correctly. Right. So I think this should only be done. Yeah, after the exit condition, right? So this should be done right here. Right. This makes more sense, right? So only after the subdivide is complete, we actually allowed the pool pointer to move along. Alright, I think this should be correct now. So we place a breakpoint here again. Yeah. So nodes in here. Yes, this looks correct, right? So if the root nodes, that's 0, and then 1 subdivides again, but then is terminated and is 0 till 19. Root node 2 is also terminated here, and it's from 19 and 5. That's big. That's actually big. So in theory, this should build the PVH now. That's awesome. And it's actually surprisingly short code, right? So now I'm wondering, now we changed the code, if it's actually going to behave with the cow. So let's see if that runs. Hopefully it should. But it might still take forever, because it apparently is quite expensive to do this. But we could potentially decrease the number of binning positions to speed up the process. And to even speed up the process further, we could do this once, this really expensive operation, but then store the result. Alright, so this is still really, really slow. However, it seems to be actually rendering. Oh, right, I never put a breakpoint down. Sometimes I swear I'm stupid. Okay, I might actually be stupid. No, just, it's fine. Whatever. Because the CPU shouldn't spike till the actual rendering is taking place, right? Because the creating of the BVH is a single-threaded process, but the actual rendering is multi-threaded. So I saw a massive spike, which should indicate that the BVH is done building. Right, so this took quite a long time, but that's reasonable. So the pool pointer is 15, so that means that we have a decently deep 3. But yeah. So subdivide, no, so right. So yeah, we're ending up with about, it seems, not that many in a node. Although the count here worries me a lot. This 11, because that seems like a way too big number for it to make sense. Because it should be quite small, the number, right? So let's just follow this, right? So 0, so this points to 1, 3. Right, so these are all branching nodes with the count 0. And then these are termination nodes. So node 11 is massive. Like, actually massive. What surprises me, because it shouldn't be happening. However, it might simply be that we can't find a better cost. Because this would be like a expected number, right? Like a count of 3, 20, even that's still quite high, but this value is so out of place that it's confusing me. Because that would mean that would have if we enter this node, right, we would have to check way too many nodes. Right, so let's see this cost function again, just to be sure. Because maybe we simply did something wrong. So according to the spatial splits tend to increase the cost of a split, right? Apply spatial. Okay, so the idea, right, is splitting has a cost. So the idea is to determine the cost of optimal object partition, then determine the cost of the spatial split, and then apply spatial split only if the cost is lower than the object partition, right? So that would be basically this formula, right? So if the surface area of the left times the number of objects in there times the surface area there times the objects there is oh, wait a second. Wait. Right, so this is the first node, right? So let's put a big print here. Because I'm feeling something is wrong here. Right. Right, so the pivot is 5,000. So what is the count? So you're telling me that the split is... No, you know, I can actually believe that, because we might be able to eliminate a bunch of objects early on. Right, sure. So this count, this count is so the right node count is not a lot, and the left here is not a lot either. So this is 0 plus the pivot, right? Sure. But this left is 0 still, and the count is still very big. So then we go into the first subdivide, and the cost here is quite a big number. But this should be a bigger number. Yeah. And this is then again equal to, right. So the left node is 0 still because, yeah, sure. But the count here, it's 43. We're only, each time we're cutting a very small portion. What I find odd, because we should go about 50-50, right? We shouldn't be cutting like this little objects. Especially since the final one shouldn't be... so let's actually go to an end and see what kind of end we're getting, like how close that difference is, because maybe I definitely think something's wrong. It's a shame. I thought I was really on a roll, right? But I think it's a bit early to judge. So this is 13,000. 13, 13, 13, 13, 13. So this is the same cost, okay. Right. Oh, but is the pivot by any chance the same as the count? So it's 5,536. 5,536. Okay, right. Nah, there's something going wrong here. because this would indicate that the pivot failed, as in nothing got split. What sounds like no, wait, yeah, no. It's not the total surface area that we care about, right? It's the cost thing here again. Yeah, right. So we only care about the cost of splitting is less. So this shouldn't be equal to infinity. No, they should be equal to right. Yeah. So this should so this shouldn't be surface area. This should we can still have that, but we want right. No. We want to calculate the cost of the split, right? To see if it's the value. Right. Yeah. So we don't want to calculate this here. We do need this. So if the surface area is infinite, no, we don't want that. We simply want. Yeah, no, this is infinite. No, sorry. So we do want a float. We want a float cost, and this is equal to infinity, right? So if this is less than costs, right, and cost is equal to surface BL times pivot plus surface. Sorry, this would be BL plus surface BR times count minus pivot. Right. And now we should have a proper cost function. Yeah. So now they should actually see if it's worth this. If you actually get the cost of the split here instead of the surface area. What is wrong, I think. Right. So let's see here. Right, let's put a breakpoint here again and run this again. Now we should hopefully see a much better split. So now hopefully there should be about 50-50. We shouldn't get massive values like 5,000, right? What makes no sense. Do I even need to... I just realized that we're calculating cost now twice then. Oh, we're done. Right, cool. Let's worry about the cost later. Right, no, so we still have the massive one here. So that's a pain. Right, so we don't want to do it until infinity, but we want to do it till... I'm kind of curious, right? So let's print out some information. All right, so I want to printf info, right? So I want a percentage f. So axis. Let's just start with the e-axis, right? Info dot split axis. And just goes us to no, this shouldn't be a double, should be a long, I think for, anyway, it should be fine. Sure, and then /n, and that just goes to a long, sure. That's fine. Let's print out the axis that we actually end up splitting on, because I'm curious if it's L every time the same info. This is odd. Right, apparently we can't cast that. That's cool. Sure, let me recompile that. I might have just messed up the printf formatting. And just reading garbage. That would not be that unexpected. Right, sure. So that's Z. But that's taking indeed an awful long time to calculate the right. Now something is going wrong here, because it doesn't make sense for the z-axis to be at every time. And why is the end done so quick, right? You could see the end was like immediately bam done. That's odd. Right. So let's look over the subdivide code again. Right, so this one is at the very end, cool. So we look over the 3 axes, sure. So this is axis. So we don't actually need this value. So where is this used? Only here. Right, so this is just a temporary value that makes no sense. So we can simply pass in axis here and bang, bang. Sure. So we loop over all the axes and then the number of splits. Sure. And this distance, what was this distance? What's this thing used for? Oh, right, yeah, no, right. This is important. This is the distance of the current axis, right? Could it simply be... No, that would be odd, right? Yeah. So then we see current split point is bound 0.axis, yeah, plus y times inc, right? So that gives us the actual split point on the axis. Then we sort it, and then we triangles begin first, first plus count, sure, and then we pass in the axis. Then we say return get center of axis is less than the other axis. Sure, I believe that. So we're now sorting based on the thing there, yeah. So then the bounds here, I believe that as well. So it's the triangle is first. This is odd. Oh. No, this is... I think this is okay. Right. No, yeah, we get the current triangle. What is... First. Yeah, what's the first and then first plus count? Yeah, no, that's completely fine. Although, do we pass in the correct first? Yeah. Yeah, no, that's correct, I think. Let me just breakpoint this just to be sure. Just for my visual seeing, right? Right, so that is first 0 count is 5,000, blah blah blah. Right, let's do calculations, and it should breakpoint at some point here. Right, first blah 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 count blah blah blah. And then first now should be something else. No. Oh, right, because we first subdivided the left again. Sure. So at some point, first should be something else. Theoretically, first should be something else at some point. We will see. We'll see. Yeah, there we go. So this is now splitting, trying to split this, right? So it starts with triangle. Yeah, so it would start with triangle, blah blah blah, and it would do these triangles. It would only check that part, right? So first, yeah, it would only sort this part. Sure. Okay. No, it's that part is being done correctly. So if the axis, right, is less than the current split point, yeah. Yeah, so if it's on the left, it will do the bounce left calculation, and yeah, cool. So it will calculate the bounds of the left and the right. Then we check the cost function here. So if surface BL, yeah, sounds pivot, yeah. So what's the cost that we pass in here in the beginning? It's infinite, but it shouldn't be infinite. No, it should be. It should be passed in actually. Although. Right. Where do I calculate it? Right. So the cost thing here, right? Right. So in here we need to pass in the floats, current cost. Right, and then we pass in the cost, and then this should take another float. Right, and if this is right, so we actually pass in the cost of the parent node, and we only really care about the option if it's less than the passing cost, right? Because otherwise it's still not worth it. So let's see the first thing here. Right. So let's go to printf. That's a bit better. Wait, did I take in negative numbers into account? What if it's sorting it wrong? Because it takes in, right, it sorts it on based on this, right? So why does it always picks the Z? Always. It always picks the Z. Why does it pick the Z? Why does it pick Z? Right, so let me think real quick, right? So we start with we sort based on the center of the triangles. And if it's below, no, we just sort them on each other, right? So say we have an object in the minus, no, that should sort correctly because it's just still smaller or greater than. But why is that always picking Z? Right, so I'm kind of curious about what kind of, let's see just what kind of pivots we end up with. Right, so this should be, yeah, this should be here. Actually, sorry. So we end up with a pivot of 161. That seems reasonable. Yeah, these are more reasonable numbers. Oh, wait a second. What if I am simply doing one split too many? Yeah, what if it's picking these high numbers because it basically putting the split axis on the very, very end, like over the edge, what would produce weird results. So let's see, let's try this. Huh, interesting. It seems the output is a bit weird here, right? It should output the game, not the, or sorry, the Raytracer, not the weird ass. It's odd why it does that. It doesn't scroll either. Okay. I think it simply hasn't loaded in. Oh, that's a lot more accesses. Now I'm seeing some different values. Right, that looked more promising. Right, so what was the cost here? So 17, 27. Right, so we theoretically can still continue here. Okay. But this is providing a lot of info. Because let me scroll the way up. Oh wait, this is actually producing completely different results. Wait, let me pause this. Let me stop this again and return info. Right, let's debug this again and see the differences. Right, so open the console. So this is 2. Oh, I'm actually at the console here as well, so you guys can actually see what's happening. Right, so it's 2. 2 again. 2 again. What I can believe, right, because the cow might be quite big on the z-axis, so it might try to split a bunch of times on the z-axis first. So what kind of value are we getting for the pivot? 4,000, and the count is here. It's still pretty big, but oh wait, let me actually see the. Let's store another temporary value just for debugging here. So float. No, sorry, this should be int split. Let's split index, because I'm kind of curious what this will evaluate to. So right, so split index equals, I think, just I, because I should be, yeah, right. So let's rerun this. So maybe we can see something interesting here. Right, so the let's actually not use breakpoints and simply log this info as well. Axis split index. All right, let's try this. I mean, this is gonna crash because it's still the same value, right? But we can now actually see what kind of index it prefers to split at, what might indicate a fault in the project. Because we can see it keeps preferring the very, very last index for some reason. And now we see that we're cutting down, but still getting near the edge. And ideally, it shouldn't be near the end, right? It should be somewhere in the middle most of the time. Because if it's in the middle, that would roughly mean that we're getting 50-50. What should be normally ideal case. But yeah, it's either 0 or like near the edge for the most part. There are a few weird outliers here, but it seems to always pick the Z. Oh, I think I know why. Or Z is in the negative, so I think it's always picks the Z in basically the wrong direction. Let's see if we can compensate for this. So X is so if axis equals 2, then inc times equals -1. It's not very pretty, but we can check here. We can try here the Z inversion. So we can simply say the increment is the other way around, because I think that is what's going wrong here. We could fix this another way, I think, but that's fine. Oh, sorry, I need to check the console. Oh, but now it's taking X as 1. What would be the Y? What actually makes sense? Is this gonna run out of memory? Probably. Maybe not, actually. Did that successfully run? I'm still hesitant about these values, but this seems at least more promising. These are values I would believe BVH is successfully made. Or at least let me put it like this, these are more likely values, but we're still almost exclusively splitting on the x-axis. What I do think actually is correct, because I can open up the model in a second if it actually renders, right? Sorry, this should be the Y. Yeah. Let's hope it actually renders the cow in a reasonable time in the CPU. On debug, what is actually horrid. I do think that we might simply be going wrong with the increment here. I've got a gut feeling there that we're simply going wrong there, because it still always seems to prefer the still usually the either like the very first wouldn't make sense, right? But we have the cow, right? So I would expect either the y-axis or the the x-axis or the y-axis to be picked at first, because the cow is quite tall. I think there's quite a lot of vertices in the hooves, right? So splitting on the Y might make sense. Wait, let me actually open up the OBJ, right? Right, maybe this actually might make sense. So let me add the window here real quick. So window capture 3D viewer, right? 3D viewer, right? Let's see if this pops up on the stream. No, okay, that's absolutely lovely. I had hoped it would pick up, right? I can share my screen real quick. That should be fun as well. Oh, right, I had the... can I put the 3D? No, I can't. Okay, cool. Oh, sure. Let me just open this real quick. It should be fine. So the legs aren't really that high poly either. I think it's kinda the same poly count all over, pretty much. It isn't anything that special. So I don't think it's should split on the Y first. I think it's should split on the X first then, because there is the head as well. The head is clearly the highest poly count. Right. So let's actually check the increment thing that I was thinking about. So, right. So the increment is 0.6. What could be the case, right? So let me just check this. This is -4, and this is 5. Sure, yeah, so 6 roughly, right? So that divided by the number of splits is, so that the distance is about 10, sure. So the increment is 0.6. Okay, I can live with that. So, yeah, we want to start with a very slight jump. Wait, so index 0 would still mean that we're actually splitting of objects. Right. So the current split point, right, is minus... That seems wrong. No, that's actually correct. Never mind. Yeah. Right, so let me check something, right? So calculator. So if this is 15, so the max value this could be, no, this doesn't have to be -1 actually. So the maximum value that it can have is 14 normally. Would still be one below. It wouldn't be at the very edge. Right. So 15 times 0. What was it? 65 ish is 9.75. Is that about right? That should equal to plus minus bound 0, so it should be minus 4.44. So that is equal to 5.31, which should be about this value. Yeah, close enough. Yeah, no. Yeah, so if we do plus 0.66, yeah, that's about 0.97. What is 5.97? What is this value? Roughly. We're rounding not that much up. A few numbers, plus or minus is fine. So why is it still picking those values, right? So it's still checking the... Could the get center simply be wrong? I think this should be okay. Let me double check. Not right. So we do actually want to... I think we want to do it at 0 and greater than or equal to. So let me read up on the binning thing, right? Yeah, so the binning seems about right, speed-wise maybe. Yeah, who knows. So let's rerun this, see what this does. Wait, actually I do need to check this. So if the increment equals, the Z is selected, right? Yeah. So increment is now minus, sure. So the current split point and bound 0 is minus 1.7 something. Yeah, sorry, so I need to check again because it's times 0. No, we're going in the wrong way. Yeah, we're going backwards. Yeah, so this should go. Right, if I'm correct, yeah, because we're now only going the wrong way. Yeah, and bounce 1 is in the positive. Yeah, so we do actually care about that. So that is actually very important. Yeah, thank you, Jinx. You have a Merry Christmas as well, man. How's it going so far with your Christmas? Got any good cookies done? Baked? Alright, so let's see if this crashes. I hope not. But still, it bothers me that it still keeps picking the end value down, and that's impressive. I actually didn't do that much with Christmas. So yesterday I did have a family gathering with my dad. However, with food wise, I didn't do much special, especially since I'm doing keto. I can't eat much special food like candy or stuff like that. So it's mostly been just regular food, but just in the holiday spirits, right? Wait a second. I'm curious about something. Yeah, it's an interesting choice indeed, but it's actually so far of all the diets I've tried, keto is actually the only one I've managed to actually get going consistently. Because with calorie counting, it's very easy to just say, well, today's a cheat day, right? But with keto, you can't really do that because if you cheat one day, well, you're kind of fucked. So I'm curious about something. If it's always picking the Z, why does it run this? So let's think about this. Let's say I messed up the... What if I messed up this, right? So there are two Zs, there are two Ys, and two Xs. XX, YY, ZZ. ZZ. So let's put a breakpoint in the... Wait, delete ships. I did need this actually. I needed the increment thing, right? Because that was actually wrong. We need the... We needed this, right? Wait, I forgot if we needed it or not. Damn it. Let me double check. So this should be here, there, current split point, yeah. No, this was actually wrong. Cool. I forgot what was correct or wrong. That's done. Okay, cool. So why is it always picking this one? Right, and the axis is 0, sure. Right, so it does seem that the closer to the center we seem, it still seems to be taking about the center. However, it seems to still prefer the left, because this should not actually be bigger. So the surface here, surface there, sure. So it's the pivot, right? So that's, how much is this? This is 2000. So this is roughly 50-50. I mean, we can just see the total source. Sorry, yeah. Sure. I believe that. And this value is 80 something thousand. Sure. So this keeps going till 15, right? So this surface area should be almost 0 now. Yeah, because the count here is so the pivot, yeah, the pivot is like almost there, so this should be like 20-ish or something, right? No, 344, sorry, my bad. So according to the splits, this should have the lowest cost. So if we highlight this, so the other one was like 86. Oh, I'm stupid. I see the issue. Right, so it's checking the cost, right? It's comparing if it's actually less than the beginning cost in the first place. If it is, we can't do it. But the lost cost is still less than the other one, so it simply overrides the actual better value. So we need to set cost. Float splitting costs, and this is equal to, right? I see the issue finally. So if splitting cost is less than cost, then cost equals splitting cost, because we need the optimal. So now, right, this seems better. So 5, 6, 7. Long pause, that's good. There we go. So now the split axis is X and 8. What's about in the middle? That should be correct, because the splitting should happen roughly in the middle. So now if we go here and just let it run, we see it keeps splitting in the middle. Maybe that looks more reasonable. And I'm willing to believe it is fine with it at like the left-ish. Okay, it's done. It's not crashing. So let's inspect these values, right? So how could 0 ever be an option, right? Because it would be at the very edge. So that would basically mean that there is no better option, but then later on it still splits. Oh, you know what might be happening here? It's x is 0 split in x 0. So what if it's simply invalid? Let's add here a invalid one. Invalid, and this is equal to 3. So the this one is equal to axis split. Oh, so info dot split axis equals e-axis dot invalid, right? So it by default it's an invalid axis to split on, because maybe it's not worth it. So maybe we can see here now that the reason we're getting weird values is simply that it's not worth it to split. Oh, this is odd. Oh. Yeah, right. So if it's invalid, right. So if invalid, so if partition info dot so if info dot split axis equals invalid, e axis dot invalid, simply return, and we don't need to sort. So if we didn't partition, we don't really got to resort. Because we don't got to resort, because we already know we reached the end. Right, and I do actually need something in here. So this is in the partition info, so we have a float splitting cost. Right. And we simply set, instead of this partition info, so there should be info.splitting cost equals splitting cost. And info. So let's actually begin filling this up. So the info is, what kind of values do I have? Split axis is E, axis dot invalid, 0, cost, current cost. What else did I need in here? Yeah, this is all the values I really care about. Sure. So surface area. No, I think this should be okay. So we just pass in the first three values. And this shouldn't then be cost, this should be info. No, we actually don't. We don't need to fill this in. We only set the axis to invalid by default, and then if this is less than cost, we simply set cost still equal to splitting cost, right? And we just set the value here. We could recycle it, but it's fine. We're passing it by value anyway. Should be completely fine. So now we're still setting value. Ding, 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 ding. Right, and now we have the cost here. Why is it complaining here? Oh, this is assignment, whoops. And then we actually already know the cost here. And if cost, you don't need to recalculate this here because we already know. So if partition result dot splitting cost is greater or equal than that, stop it. We don't split. Let's run this. They should now produce correct results. In theory, right? I haven't tested it. I mean, we're testing it now, but you know what I mean. I really, really hope this works, because if this works, it's massive. Because I think creating a BVH is one of the harder things in a Raytracer. I know when I did this for the first time, I was stuck on this for like 2 weeks. I worked on it like for 2 weeks straight, and now I've been working on it for 2 streams, so about 4 or 5 hours. Well, it's still a long time, but it's taking longer because it's taking relatively long still because I'm taking a different approach. So before, what I basically did, I don't know if you guys are familiar with a bounding volume hierarchy. In case you're not, it's basically a way to subdivide space. Let me get an image of a bounding volume hierarchy to just explain the concept, right? Right. So I think this is a decent image, right? So in the bounding volume hierarchy, right, we have oh, this is actually a perfect image. So we have objects, right, that we subdivide into boxes, and then we're going from box to box to box, and basically subdividing the space. This allows us to skip a lot of intersection tests and can speed up our process by a lot. But it's quite hard to mentally think about. But the thing I'm doing different than before, because normally what I did in the old Raytracer, I looked at like what side of the box is the longest and just take the middle there and then play along there. That should be good enough. But now I'm testing a bunch of different possibilities on every axis and actually seeing, hey, what is actually interesting and what isn't to split. So this will give us better results. However, it's bit hard. It's quite a bit harder to actually visualize and create. So why is it not running at all? It's not printing anything. Right, let's just rerun it. Right, because my CPU usually was literally 0. But very odd. Why is it dropping? Huh? Is it never reaching this? Huh? Wait, let me restart. This is odd. What is it currently doing? Call stack. Okay, interesting. Very interesting. I am curious why it's not triggering any breakpoints. Right, there we go. Okay. I just think Visual Studio had a yeah, I think Visual Studio just had a mental breakdown for a bit. That's fine, I guess. Right, no, but these values make sense to me. It's nowhere, it's almost nowhere at 0. Yeah, no, this, and it's actually quite fast now compared to before. This is starting to make sense. So now only wanting to check is at the very end to see if sorry, at the very end to see if the actual counts make any sense. Oh, in the nodes themselves, that is. Because we should not see too many shapes in each node. Hopefully. Right. So let me enlarge this a bit so we can actually see it. Right, so scroll down. Right. So we're still getting quite a high count of like 38, 64. But that is manageable. Those are way more manageable numbers. A count of 7. I think this seems reasonable actually. These kinds of values. 12, 20, 1. Count 0, that's odd. This seems kinda odd. Because a count of 0 would indicate that there are no shapes in this node. But it's pointing to node 16. But that wouldn't make sense. Because node 16 references to left 75. That refers to 77, 79, 81. Yeah, and this goes on. So 87. And that 87 is an actual leaf node. However, we're getting empty leaf nodes. What doesn't make sense. Because according to our setup, an empty leaf node would basically mean oh, but you know what I could do? I think I know why this is happening. So we're setting the subdivision to be still. Let's change this to 1 and yeah, I think like this. Right, I think this should make more sense. Because I don't think we can now get this anymore. Because it might take the split at index 0. And that would not make sense. Because that would basically mean at the very edge of a bounding volume. And that would be containing 0 shapes. Yeah. Ships. I forgot to set a breakpoint. That sucks. Because that means we have to debug it again. I need something to drink. Oh, luckily I have some crystal clear in my room. Product placement. No, I wish. Okay. There we go. So now if I identify the nodes again, if we go down, we're still getting nodes with 0 objects in it. That is problematic. Because we can't have nodes with 0 children. Because that's a... This is actually an illegal situation. Because we're getting a 0 here would count 2. So that would mean... No, this is actually impossible, right? So this code is basically saying, hey, we're starting from index 0 and we're taking 2 objects, indicating that this is a leaf node. However, node 326 here is also saying, hey, I start at left 0, but I have a count of 6. What doesn't make sense? Because you can't have the same count. You can't both be a leaf node at 0. That's impossible. That actually is impossible. However, I think I'm gonna call it here for today because I'm quite tired and I've been streaming for about 2.5 hours. So I think I'm gonna take a break for today and maybe stream a bit more tomorrow. Thank you all for watching and have a good evening.